So, perfect. So for our today class, we're going to check this best location exercise and have some discussion on that. So, in our class, we haven't, let's say, discussed a lot about the interface of the ArcGIS Pro. And in general, for GISs, we were, let's say, more theoretical in the first classes rather than having some discussion in here. What I would like, first of all, to mention is to have our data very well structured and very well filed. It's the uh, most important thing in a GIS. Okay, so for example, the example here, you see I have created a folder, okay, for our on the right. I mean, can you see my screen? I mean, good, not
Yes.
small letters. The fonts are okay, right?
Yes, it's okay.
Okay, thank you. Um, Sometimes the analysis of the screen is high and I don't know how you see that. Okay, so on the right, here in the catalog area,
I see it a little
we
blurry.
manage,
Sorry.
excuse me,
The screen. It's a little blurry for me.
blur, this is a matter of internet connection.
Ah, okay.
Probably give some time and I think it will be, for the
Okay.
rest, is blur or clean?
It is clean, I think.
It's good.
Okay, so it's a matter of personal connection. If it was the opposite, I would be blurred for everybody, so my internet connection would be a problem, but in this case, not. So, uh, it's the filing, okay? It's the managing the data. It's very important to have everything clear, all your data saved in specific folders. It's better to have many folders uh, separated rather than everything in one place. Okay, so for example, here you see I have extracted all the shape files that we use. Okay, this is the initial shape files, but I have created in my folder another one, okay, which says deliverables. Okay, so I don't want to mess with my initial folder in order for me later on to work with the data. And always when you are going to, let's say, uh, do some procedures on your data that may affect your data, for example, like a clip procedure, okay, which will reduce the size of your data in your screen, on your screen, or in the database, okay, it's the same thing. It's better to have copies of that and do not mess with your initial data. Okay, so you will see that I'm going to emphasize on that a lot of time during our classes because it's very important for you to work on GIS properly. So here we have all the data that we were given from the public bodies, okay, because we want to emphasize also that we have different public bodies giving their own data and their own, let's say, specifications for that, okay, and we wanted to work on that. So we had some major watersheds here. Oh, wow, everything is pink. Okay. So we have some slopes for a specific area. We have the national forest here. Where is my selection tool? Okay, here. We don't want to work only on major watersheds. but we work also in sub-watersheds. It's very important to understand the area and how this area is, let's say, interacting between them. And we have the vegetation for the forestry and the state park over here. Okay, still we have some highway, like Eleni mentioned, that we didn't use it in the video, and of course the streams. So I won't go through the managing of the symbology of its layer, of its shape file. If someone wants to have a talk about that, please feel free. I mean, you already have another class focusing on that. I think you understood that we can change colors by selecting them, but also colors have their own codes. So for using the codes, you may select specific colors, even if they are RGB or CMYK, which sometimes is very important because if you are working for, let's say, some Greek public authorities, usually they give specific colors in order to interpret the data. Was just an example because I do know from the Greek public bodies that they do that. Okay, so let's go to the first specific issue, and also Vasilis mentioned he had a problem with the dissolved boundaries. Okay, so in this exercise, let's say we don't want to change our data, to interfere with our data. So that's why we are using the methodology of the filtering of each layer. Okay, so for example, in our sub-watershed, we in the symbology, we went to the filter, to display filters, in order to set our 3 filters. Okay, so this is, let's say, a lighter version of SQL, okay, with specific orders. And in this case, I want you to remember what we discussed in our first class concerning Boolean logic, but still this logic is applied everywhere in softwares and in general managing softwares, is where you have to give an order, okay, to the system and say maybe you give multiple orders to the system and you want to set how it will interact with your data. Okay, so usually there are two options, the and the or, and as we already mentioned about that, is that the or covers all all the options individually, the options that you give individually. But if you put the and, these options has to be applied on the specific data on the same time. Okay, so in our case, because here we're talking about the physical body, okay, the watershed, the sub watershed, this cannot be done physically. I mean, a watershed cannot be the watershed 550 and 556 on the same time. Okay, I think you do understand that. So if we put an end here, this whole procedure, and we can, why not? We can do that. Let's put an end here and apply. So nothing happened. Okay, but if we use again the OR and then apply, you see, here we have, it worked, okay? So the first thing that I wanted you to understand here is that by using this filter, we excluded the rest of, let's say, our information, okay? So give me a moment, because we have all these. Here we are. Okay, so, and you can set this query here and turn it on and off whenever you want, okay? Another thing that I didn't mention, I think, if I remember well in the video, is that the whole thing, you don't have to do it from the very scratch. So if you want to use this query, not only on this data, but in other databases that may have this information in there, okay, you can save it as you see here, okay, and create it as an expression for the future. So we will use that, okay. So let's go here. I go to the project here in order to find my, let's say, folder that I have connected. So it's very easy. I don't remember if I have mentioned that to you, but it's better to not use the folder of the default where the ArcGIS is saving all the information that is producing the whole time. It's better to use another folder, so your own folder. We are going here. Let's put it in the deliverables, and we can save it as shed expression 1 and save. Okay, so good. I turn it off because we want to see our whole data. Okay, and probably I want to close this, so sometimes it may affect, your observation. And I want to mention another method. Before doing that, excuse me. So if you have opened the filters, still the database has all the initial information, okay? So we don't affect our data, we affect only the visual part. This is very important because you have to, you understand that in this case here, our data are safe, let's say, we haven't modified them at all. So we mess up only with the visualization. What this means is that the system still knows that here in this shapefile we do have this data. So if I click here, you see I still interact with my database and is locating this specific data. Okay, also here, even if they're not visual, okay? So we have to understand
Yes,
that.
something.
Yes?
I have applied this filter, but now that I have opened the project, I don't see the expression. The filter is on because I see the other not non-visible polygons, okay, but I don't see the expression. I mean,
So you're going to the symbology, you're going to the filters, and you don't see your applied
this,
symbology.
yes, I don't see this this expression here.
Okay, you're doing that on the sub-watershed, or
Yes.
I think through the exercise you may have produced another shape file. Maybe.
No, it's in the sub watershed, and I see also the attribute table that all polygons are active. But visible are only those three, 550, 569, whatever. but I
Mhm.
don't see the expression.
Okay, this is weird. I mean, if you only see those three and the database is like mine, I mean the initial data,
Yes,
you should have this kind of filter.
yes.
Maybe you can remove, let's say, remove the save file from the system and then just insert it again and check from your catalog and check again what's going on.
Okay.
Maybe it's stuck. I don't know.
If I remove the save file now and then also the filter will be gone. So I will have to do it again.
I will do that for you. Give me a moment. What Subwater said. You see, I took it out.
Yes.
I put it in, so the filter is out.
Uh-huh.
And also here the display. I told you to do that in order to unstuck it. That's why. But in
Okay.
my case, I don't mind because I saved the expressions. So I put the load, subwater expression 1, and voila. This was a very good display in order for me in order to use the expression, how to load an expression. So
Okay, I will try it.
it's better to unstuck it. I don't know, maybe during your save of your project something stuck. Who
I don't
knows?
know. It's okay.
It's my first time to be honest, encountering that. I mean, it's just a simple procedure uh, for the GIS and the system. I mean, okay, so we
Can I ask something? I'm
yes,
sorry. Um, how you saved your
okay. Let's go
expressions,
back.
you can say, your selections, just from the icon.
Still, I haven't saved the selections. I saved the expression. So I open it again. By the toggle, using the
Yes.
toggle, it's simple. Okay, turning on and off. While I'm setting the expression here, or you can do that in other also tools that are using expressions. This this is the same thing. It can be done everywhere. You just hit the save button. If you hit the save button, come on, I have to do something else. Give me a moment because I probably have to add something.
Mhm.
Okay, yeah. If you hit the save button, it will create a file as you see here, okay, which is a query expression file. Okay, it's a specific file, exp, which this is one of the very classic and old type of files that our GIS are using, because in the past the queries are well, still it is, but now we have automated a lot of stuff. But in the past, queries were the most, let's say, important thing in order to give um, orders to the system on how to work on your data. Okay,
Mhm.
so just doing that, saving this expression, you can use it everywhere, which includes a database, these inputs. So you have to have a database with a row of hack5 underscore ID, okay, and these numbers. If you have that, also in different kind of layer, you can use this expression and apply it and keep it and move on with that.
But the data will be different to another.
It doesn't matter. That's a good thing. The GIS and let's say, excuse me, it's morning. The GIS is searching, let's say, in your database the rows that have this name, hack5_ID. So wherever you have this kind of name, because your expression, it has there, it will find this name and it will run through your data. And if you have these numbers, it will apply exactly this filter. If you don't have, let's say, in your database, let's say that you are going to upload that, and in case you don't have the 569, it doesn't mean that it won't work, but it won't provide you this kind of filter, okay, or selection, let's say. So it will provide you the 550 and the 556.
Mhm.
This is a very important thing sometimes because you will understand further going through this master course, not only this exercise, that queries can be very long, not only 3, let's say in our case in this exercise, but they can be, I mean, with many different expressions, many different combinations. Sometimes you have to use also add and end in your data, and not only is equal to, for example, which is the most easy part, not just clicking and it's the default selection, but you have to put more restrictions, less, greater, okay, in your data. So you don't want to do that all the time. So you have to save it, okay, and just whenever you want. Like Vasilis now, for example, he's stuck with his data. It happens. I mean, it's a software. Sometimes you can encounter this kind of situations. So just by clicking the load, I didn't care. For example, just load it, and that's all. And I will showcase you another thing now, where I can use this expression. So, anybody other questions on that? It's good to have some discussions. That's why I'm going step by step, because there are several parts that are very useful. I mean, generally. Okay. So let's turn it off and let's go back to another part. Okay. So, as you have already understood, in a GIS system, you can do the same workflow in different areas here and there. Okay. So now we are applying filters as a methodology using the symbology. So using the visual part. But there is another filter which still does not affect your main data, but it will affect your visual part and your database. And this is very useful in many different cases. Okay, so in order to do that, you have to go to your save file on the content, right click, properties down there, and here you will find many different information about your data. Okay, but there is another one which says definition query. Okay, here you see I don't have anything, but I can click here. We have still more queries to add here, but give me a moment. I want to find where's the load in this case. Aha, here it is. But okay, so the first query is to build it yourself, but the second one you can upload. So I click the load here. Again, I click the previous one that I created. I can click edit in order to check that everything is set as I wanted, and it is. Okay, perfect. Apply, and then apply, and I will minimize it a little bit. And here. And you see, I have the same result. So everything is filtered, but in this case, let's check our database. We don't have the 8 inputs and rows, but we have only those that are visualized. And you see there's no any interaction, I mean, by the selection here. Okay, and we don't have anything here. So this means that whatever we do as a procedure in the shape file now, it will take in account only those 3 different data. Okay. This is important to do it in case in case you care about your database, and by working on the database and your visual part, instead of using the filters here in the symbology, which you may do want to check your database all the time in order to see what the content is, but to display different things. And this also affects how you use the other tools too. Okay. I don't know what they got me. So let's go back and close this query. Edit. There's no, in this case, there's no and turn on and off. So it's only, okay. This is clickable. Good. Okay, so I turn it off. Everything is back. Okay. And remember, the first procedure that doing this exercise you wanted to do is to dissolve boundaries, right? Of the sub-watershed. Okay. So I go to the analysis tools, and somewhere here I have it already. Dissolve boundaries. Perfect. Sub-watershed. Okay. In this case here, we gave the name of the cougar habitat, right? Which in this whole area, let's say the cougars were running free and they live their own life. And then we run this tool, right? But if we run the tool like that, the final product will be this is not it. Okay, let's check now. I will do. We will get this whole work. Okay. Give me a moment because yeah. Okay. So here we are. So while doing the sub-watershed, okay, we created this shape file, and this was homogenized. And if we open the attribute table, we see that here we have only one element, but it is important to see that in the count, because now we have a different database. Okay, so the new shape file has a different input here. It says count 8. The count 8 is how many elements were homogenized in one. Okay, so here we have 8 in the first, in the mother, let's say, database, and the product has only 1. So we do know that 8 elements were merged or homogenized. And you're getting this kind of information, but we didn't want 8, we wanted only 3. So let's go back to the subwater set that I am here, and let's say open up the display filters, the 3 filters. Okay, oh, here we are. Perfect. I will doesn't matter. Okay, I have it on. Let's go back to the job process. Still, we have the subwater set here, so we can play with that just by running the same tool. I will keep this name here, okay, and hit it. Oh no, still the same result. And this is done because here in the database we still have 8 the 8 elements. Okay, but if we go back, doesn't help with the symbology color. Let's do that here. Okay, so let's go back to the definition query and open it and apply it. Now we have the 3 in the database, and we can go straight back to the job process on the subwater set, and now hit the output feature class of Cougar. So in this case now, I don't like why they are using the same color. So in this case now, the output of the dissolved boundaries is the same as our definition query. Okay, so keep that in mind, that in this case is working very easy. Another way to work is to go through the elements and selections and etc. But this is, let's say, a more indirect way. I prefer, or just prefer better the direct ways. Okay, so always is another way how to result to the same thing. Okay, but I prefer this. Okay.
So in order to make the dissolved boundaries correct, we actually have to first to change the database, the attribute table actually, yes, the database.
Not to change, to filter. I prefer.
To
filter it.
the
By
filter is only about the visualization. It keeps
also the
8 polygons. So when we're going to dissolve, it's going to dissolve 8
everything.
the boundaries of 8 polygons.
That's
By
why,
doing this definition query, we actually change the database.
to be honest, you don't change it, you just filter it, but also you filter the database and the visual part. You see, just by clicking.
Yes, I mean to make this query, and yes, it doesn't change the database, it changes the attribute table.
Exactly. Well, the database is the attribute table. That's
So
why
we
I'm
changed
talking
the
about it.
database.
Mhm.
Instead of 8, we have 3 polygons.
But still, there are the other 5 there, but you don't display them as data.
Okay.
But still, in your specific file, this is the most important thing. In your specific file, the data are not gone. Okay, they're still there, but you don't manage them. The same thing can be done by creating a new file, for example. Okay, we can talk about that. But doing that, you are going to produce more and more and more sub files. For example, okay, let's go to the most uh, to- now I dissolve the boundaries. Wait. Okay, still there. No, it's the symbology issue. Okay, doesn't matter. No, it does matter. Sorry. Here, yeah, good. So, I went so back. Here we are. Line. Okay. So, Vasilis, I got the same issue like you. I don't see here the expression, but if I turn it on and off, it applies the filter. Okay. So it's also another kind of lag. Never mind. So another way how to work is to do a selection. Okay. So this menu here, okay, of the GISs in general is one of the most important menus by working. Okay. So there are 3, let's say, main ways how to select data. The one is just by pointing. Okay, so just clicking on that and you select the data and interact with them. The other is by giving orders. Okay, so there is the select by attributes and the select by location. The select by attributes, you select data using the information in your database. Okay, here the attribute table is the database. And by selecting by location is by giving orders how to select data on your display, okay, on your map. So we're going to go through to the select by attributes. Okay, I didn't want to have this here. I don't know why it is, but normally when you open that, you don't have anything here, so you have to create an SQL selection and query. In our case, we have it already here, so I can upload the same query that I worked, okay, and apply. Okay, and let's close it. So we see now we have selected now the 3 data by the whole thing, okay. So I can now extract only those uh, elements, those 3 elements, okay, and create another data set, another shape file with only those 3. But I will have to produce another shape file, more data, okay. So by clicking now while they are selected, by clicking on the sub watershed, we go to the data down there here. and we see that we have the option like export features. We click the export features, and here is the most important thing. The input is the shapefile, but as you see here now, you have the use the selected records 3. Okay, this toggle button. So now that it is open, if I execute this procedure, it will export only those 3. Okay, so here in the output feature class, I have to select now the folder that I created the deliverables in order to do not mess out with my data. And let's say that here we are creating the sub watershed 3 counts, just to remember. Okay, and okay. So at this, let's say, tool, you can, before executing this tool, you can already do several procedures. Like, if you haven't done it already, to do a filter expression here, or to rearrange the database of the exported file. Okay, so here you see the Hack5 ID. Here is the address and the whole thing. So if some of this information you think it's not valid, or you don't want to pass it, by exporting this data, you can delete it from here. Just, for example, I don't like this watershed number, I don't know what it is, remove it. Okay. And at the sort, it's not so useful. And here you see also the information of your data. For example, the first and the second row is numbers. Okay, so you see that is numerical, and the other 3 are text. So that's why you see these different colors here. And let's hit now OK. So as you see, now we created a new shapefile, which has only the selected 3, the previous selected 3. But now here we have a new database with only those 3 information. There's no filter. I mean, okay. And if you go to the definition query, there is no definition query. So this data set, this new data set, it has only those 3 elements in there. Still, you can work with that, and while you are like this, you can go to the job process, you can go to the dissolve boundaries, select the new shape file now, the sub watershed 3, okay, and let's hit it as it is, dissolve boundaries, and finish. Okay, so there are 2 ways how to get here in this final result, let's say. But the second way, you have to produce a new dataset. Okay. Do we understand the difference? Is somebody, has some questions on that? Okay. Okay, let's keep that here. So, oh. Okay. So in this I forgot something. Where? So in this exercise, you saw that we had to do some buffer zones. Okay, the one that we discussed on the first class. So for example, the first buffer zone that you had to produce, it was of the state park, okay, in order to find the area that we do care in order to work in there. So you had to go here, the analysis. Of course, instead of searching here at the, in order to find the tool, you can find it, let's say, here as one of the most useful tools, the pairwise buffer. Okay. For those who searched this tool as just buffer, and well, we can use that. No. Okay. This tool is a little bit old, let's say. So that's why ESRI, when you're getting in there, it says there is the pairwise buffer tool to provide enhanced functionality or performance. Okay. So you see on the right, something like that. You may see that also in different other tools. Okay. So in this case, you may use these situations, these, let's say, options, as, let's say, these optional tools are more updated in the upcoming versions of ArcGIS instead of the old-time classic tools, like the buffer one, for this example, okay? So just keep that in mind. I have seen that on several tools. So in the input feature here, where what is the state of the park? Okay, so here we have the state park buffer, if I remember well. Yep. And here we're giving the units in kilometers, and let's say the distance is like 5 kilometers. Good. So before executing here, there's something in new options from the last update of the ArcGIS that I see here. Like at the below part, you see there is an override option. Here it says that delete existing and create a new dataset. Okay. But there is also other options like append to the existing. So it will create more information in the same database, okay, and or replace. So you won't it won't create a new file, but it will replace whatever you have in this state park, let's say, okay. In our case, I prefer the first one, okay, in order to create a new file. And excuse me, this option, it was created because I have already here a file, state bucket buffer. Is it here? I think I did it. Yeah. So in my folder, okay, I have already created before our class this file, the state park buffer. Okay, so that's why I have this exclamation mark here, and which says that if I execute this output, run this tool, my data will be affected. So that's why we have now this good to have option in order to, okay, I will delete the previous file and I will overwrite, or I can update the already file that you have in your folder, okay? So this is a very new thing and it's a very, very useful. So going back here, in the methodology of the buffer zone, there are several methods. The one is the planner, as this planner does not, let's say, methodology, and you may find in different also other tools, it affects the geographic information without taking note the surface anomaly. Okay, so it looks like a 2D for that, and it works like if it is a 2D. In case you want to add also information about the surface, you have to select this geodesic shape preventing. And if you don't remember all these things, you can click on the eye of the information and you will see the full explanation about what this kind of information are, selections are working on. So I want you to remember this. Do not forget, do not bypass clicking this I, the informations, because in many cases you will find yourself on, okay, which selection do I do now? Because I don't have Giannis by my side in order to click, to take some, let's say, initiatives. So I have to do my critical thinking. So do that and you will find out which selection is better. And when you're doing buffers, if you remember on the theoretical part, there is an option to dissolve or not dissolve their boundaries. For example, to create and unified shape file. Okay, so if you do not select the no dissolve, then you can select from the other, like dissolve all output features into a single feature. Okay, and we can do that. Why not? And yeah, let's hit it. So you see, we have one just polygon. It's on the perimeter of the initial polygon. And you see now, if you take a greater look, a closer look, you see that the boundaries it's not a circle, to be honest. Is for sure it looks like a circle, but in this case each side has the same distance, okay, from the polygon's perimeter. So at this part where you have like this, I don't know how to call it, this area on the northern part, you see the shape of the buffer is a little bit more exgravating on this part. Also, the same thing is going for this side. On this side is more homogeneous because you don't have this kind of changes on the shape of the polygon, is more normalized, and you see like that. Okay, so this was done because we used the planar method, and also we see only one polygon because we dissolved everything. If we don't dissolve, and I will stick with the same name in order to not produce many data, what we are going to get? Aha. Still is 1 because in the area we had only one element on the state park, okay, because of the initial data, but we passed the information from the dataset of the database of the state park to this buffer. So we see here we have the name and the whole attribute table is here, but just for this small area. Okay, so if we want to do that, we get this no dissolve information. But in this case, in the not dissolving selection, if we had several smaller elements, let's say, in the state, okay, the state park, let me check. Yeah, it's only one, but it were more, and they were dividing this area. We had more here information in our database. Okay, now it's only one. And let's see the difference if we hit the geodesic shape-free prevision. In this case, maybe I will produce another buffer in order to see the difference with the planar. What do you think? Who wants to have a discussion on that? The same tool, the same information, but different methodology. I will press here, let's say the information button, have a little bit a look on that.
The planar is the blue and the geodesic is the
Excuse me, I didn't hear.
the planar is the blue and the geodesic is the
No,
yellow.
the planar is the yellow, the smaller one, and the geodesic is the blue.
Okay. Yes, it's normal
Mm.
because when if the Earth was flat,
Mhm.
the distance from one point to another it's smaller than when there is a curve. The curve is from point A to point B. If the Earth is planar, it was plane, it would
Mhm.
be a line. So it's the shortest distance. The geodesic takes in consideration the curve of
The
the Earth.
curve, and not only the
So
curve, also the surface.
yes, and the curve is always longer than a straight line.
So, in a hypothesis, if we were on a mountainous area, now it's not so mountainous here, okay? But if we were on a more mountainous area, the geodesic, let's say, method would be even more wider, okay? So, in our case, what we would select, geodesic or planar? What do you think?
I think it depends on the scale. The scale is the scale of the project.
Mhm.
I think it's how can I say it? Big scale. So we choose the planar. If we were if the scale of the project
More local.
yes, it's more local. For special planners, this is a large scale. Okay, I don't know how it's called in geology. If the scale was how can I say wider, okay, then we would use the geodesic.
Anybody else? Do you agree all with Vasilis? Yes, Maria.
No, just if you can explain it a little bit further so I can understand it more.
Okay.
What you said, Vasilis, or yeah, what you
Okay.
can explain that.
So let's say
Oh, sorry.
we have to go back to when we were discussing about uh, the, uh, the surface of the Earth. Okay, so we use the ellipsoid, but we use also the geoid. Okay, this is a part where we do corrections on the surface in order to work on that. So the same thing goes like here. In this case here, we don't have a 3D. We work on a 2D, okay? But we have everywhere geographic information, like, you know, your let's take your mouse here. You see that we have coordinates here, okay? So you have everywhere geographic information. So the system says, maybe it gives you the option if you will just consider what you see here as a flat surface, like a flat earthers. Okay, so these coordinates are like points on the same surface, okay, like a plate. But if you will take in consideration the curvature, the surface of the Earth, and that is not a flat, but it is like this kind of shape. Okay, so this, if you have the same points, let's say on the flat surface like that, it will be closer if you will take in account the curvature. Okay, so it's a matter of angle, let's say inner angle. So here it says if you want to work as flat earther, click the planar. But if you want to take in account the change of the geographic, let's say, or the surface of the Earth, it's better to get the um, geodesic information. And that's why it has also here in brackets the shape preserving, because you don't want to mess also with the shape of your information. And this is done because on the GIS now we're working on a 2D. So this changes the size, let's say, of your interpreting of your data. Okay. If you work on a large scale area, okay, the angles are big, let's say, of the curvature. So you have, let's say, huge differences between those two different methods. Okay, so in this case, you will have to take care for sure which kind of method you will use in order to point, uh, I mean, the interpretation of your data. In case here that we're working, let's say, a little bit local, it's not a problem to go with planar. The good thing with the planar is that you can very easily measure the distance equally in all this information, because here it just takes like it's calculating just 5 kilometers horizontally. Okay, so this is 5 meters horizontally, but in this case is 5 kilometers horizontally, but bending also on the same time because of the curvature. So it's a little bit more complicated also for the user for later on if you have to do further analysis. Okay, so there are cases we use the planar, there are cases we use the geodesic. In this case, we use the planar. Okay.
May I add another something else?
Yes, of course, Vasilis.
Also, we have to use the planar because all our data, all our other shape files are in a projected coordinate system. So it assumes that the Earth is flat. If we didn't use a projected, but we use the geographic
Geodesic.
processing system,
Mhm.
geographic coordination system, then we had to use the geodesic, but we use it projected. So it assumes that the whole project is on a flat surface. So we have to use the planar.
This is very important that Vasilis added. Yes, you're right, Vasilis. Is the origin, let's say, of our data. Okay, good.
Can I ask something? In what case did Vasily said that we are going to use the geodetic method? Like our data should be in what?
Okay, our data should be not on a projected coordinate system, but working on a geographic coordinate system only.
And how do we check that?
Oh, well,
From coordinate
yes, from the source.
the source.
Yes, the spatial
Okay, yes.
reference. Okay, so you see here you have information, let's say, on the projected coordinate system. Okay, and not only geographic coordinate system. Otherwise, it will be, just that. Okay,
Okay,
the
thank
datum.
you. Yes.
With the vector data, usually you are working on projected, usually. Okay, so I think I don't have anything to add on that. This one. Okay, so let's take a break for a quarter, and let's go back with the rest of the steps. Okay.
Okay.
Record. Okay. So, like on TV where you are putting some ingredients and you are cooking, and afterwards you are seeing the final result. So I did the same thing here. Okay. So here we see the data after the visualization that you have probably applied on your data. Okay, so let's talk a little bit for I'm going to. Okay, so we have here, maybe I will take also these streams out. Good. So we have here the vegetation. So in the vegetation, you had to change the symbology. So how you will visualize your data for your map. Okay, it's the one that we call thematic mapping. So in this case here, you had on the vegetation to select a specific thematic mapping using the unique values. So each element in your database, in your attribute table, is going to be visualized by a specific characteristic symbol. Okay, so I remind you in the vegetation we had again a lot of let's say several codes. A moment. Okay, so here it's the best way to summarize, let's say, the information that you see there before selecting anything. Let me remember. Okay, so or also here in the symbology by clicking on the unique values, and by selecting different colors for each let's say type of vegetation, you can visualize it in your data. But here I think I have a stacked filter like Vasilis mentioned. So this is weird. I'm thinking if this is a bug of the last updates. Okay, so never mind. So the initial data is like that. So except the vegetation, we have information about the water, which is over here. Okay, and the whole thing, other stuff. But for this exercise, the information that we had from the forestry concerning, let's say, the best habitats for the cougars is specific codes of vegetation. Okay, so if we have specific codes of vegetation and we want to display it and not change the database, which is our case, we can go through the filters. Open the filter. Okay, it is stuck here, but maybe I can create another one. Yeah. So new expression. So we would like to put the code, so we will use the vegetation codes. The first one is the 34. Of course, we want to use OR. The second one is the 49. The third one is 67. And there's, I think, another option for the 121. So let's save it also. We don't want to miss that. So let's code exp.
I think 121 was not in the.
No?
At least I have not written it down because I have
Okay.
taken some notes. I don't have it.
Okay.
I'm not sure, but I don't have it.
Okay, let's do it the same as the video. I don't remember, you know, just it's a hypothesis, let's say a story. So okay, let's take this out.
And I think 121 is not because it's grass, but all the others are forests. The other three are forests, so it's normal that 121 is not a place for a cougar to live.
Oh, okay. Yes. I mean, grass are. Yeah, you're right. We're gonna keep it like that. So now it's fixed. So we applied. So we exclude the rest. Okay, and we keep only the best options. So that's all from here. We have the highway, okay, that it passes through. We have the streams, and why do we want the streams? We want the streams in order to, let's say, point the accessibility areas for the cougars to have water. Okay, of course. So from here, we had to create another buffer zone, right? Okay, let's go again to the buffers. Okay, I do have some buffers already made. I don't go through that again. Okay, probably you have already your numbers from the video. So by using these streams and the buffer, this is the park. So we get, I will close the vegetation, we get this situation, right? So in order to get it as it is, as one, here we are, stream buffer, as one, let's say polygon, because it's a polygon, okay? We used the dissolve type dissolve all output features in the single feature. Okay. So by using that, we created this. But this is a nice opportunity in order to see if we don't select this and select the not dissolve, what it would look like. So let's go again to the input features. We get the stream. Let's go to our folder, deliverables, stream, buffer, alternative. Okay. Does anybody remember what distance we used? I don't remember.
500 meters. Yes, 500 meters.
500 meters. Okay, good. It's meters. Sorry. So from kilometers, we will go to meters. We use against planar. Now we are going to go to no dissolve method. And let's see. Oh, wow. Let's use another color. Let's go with red. Red streams. But it will help us. So yep. No. So let's check the not dissolve situation. So here, let's see also the database. We have again all the information of the stream. Let's see the database. This is the stream database, and again the stream buffer database. So in the case with not dissolve, we see that the tool added two more rows. Okay, so here we have the buffer distance. So this is the information that we need from that. And here you have a new ID number for these buffer zones. So it's a small buffer zone here, has its own ID and is corresponds to the specific streamline. Okay, so for example, this is the buffer zone, and I will take the stream and I will put it on the very top. Do you see the part of the stream in here? So this part of the stream, let's say it's the object ID 1. So this stream here, you see selected in the middle, is the one that for which this buffer zone was created all around. Okay, so let's go back to the stream 2. No, it won't help me like that. Let's go back to the stream 1, and I want to select this stream. So it's the 13. Okay, so no, 14, sorry. So let's take a look. We have, I know it's a little bit difficult, but it's very important, so please keep up. So we have here the stream that I show you on with my mouse. Okay, this is the first stream, and this stream has its own corresponding buffer zone. But there is the closest stream, it's the number 14, okay, has its own buffer zone, okay. So, and this its own buffer zone is this whole, let's say, area all around. In this place here, those two buffer zones, they are overlapping, okay. So, do you remember what we talked about the previous on the previous class about the overlapping of the data. This is something that it is wrong. Okay, so we have to deal with this overlapping of those areas. Okay, in the past we had to do it by ourselves, but now by using the dissolved method, this is corrected, and that's why let me close that, and that's why we have this. We have this now method. In this dissolved database, we have only one polygon with specific area and length characteristic. Okay, we don't have the information from the stream, which is something that we, let's say, we cannot deal with. Okay, as all the information summarized in one, and this is totally different. So in case you want to do that on a whole drainage system, this is the only good methodology. Okay, otherwise, if you want to select specific streams, specific rivers, you will have to go through the selection methodology. Okay, and you will have to dissolve manually their overlapping areas. As I think you understand, it is an overestimation on the part of the surface. Okay, is this understood?
Yes.
Perfect. Okay, so we have this kind of nice, like worm-like situation here. So we have another part that we didn't use is the highway. I'm not sure if this is in the video. From what Eleni mentioned before a while ago, I think it's not. So for the highway, let's say it affects the cougar, mobility, and it impacts a lot. So the cougar does not go near the road for, 500 meters. So also for the road, we will have to create another buffer zone, okay, which is simple. Just from here, highway, and if we don't remember the number, we can put also the number at the end, 500 meters. Okay, planar method, good, 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 and run. And here we are. Oh, excuse me, I forgot the not dissolve. Okay, good. And in this case, probably we will have to change some colors. Yeah. Let's go to the gray. And let's put some transparency, 50%. Yeah, why not? Good. So more thresholds here, adding up. Another important thing now is the slope, which I left it for the end. Okay, in the slope, we have only two, symbols, classes. So here we have a generalized slope map, let's say, for gentle and steep inclination. In most cases, you won't have this kind of, let's say, data, Okay, so somebody else had already let's say change it. Well, something doesn't feel right. Give me a moment. No, it's like that. Okay. So for the cougars, let's say to live, they need a more steep, let's say, area. Okay, they don't like flat areas. So that's why we have here the gentle and steep differentiation. Okay, so from that we again use the symbology of unique values, and we're focusing on the slope code. Okay, in order to get those two different slopes. From that, though, we don't want to keep the gentle, let's say. So we can go here and apply the filter. Now it's stuck, but you do understand that I have filtered the part of the gentle. Okay, so we kept only the steep. Now, we have applied, let's say, the whole, all the information that we need in order to point out the best areas for the cougar to live on. Okay, let's put also this watershed. This should be below. Okay. What else? And we have also the national forest because we left it on for the end, and you will see why. I will have to. Nope. Yep. Mhm. What else? Okay, I think we are here. So we have the vegetation, okay, and displayed only the vegetation that we need. We have here the state of the area that it is important for the maximum distance, okay, of the cougars, how to move all around. We have a buffer zone for the road, okay. We have the buffer zone of the rivers for them to reach there, okay. What else? And the slope. Okay. So there is various methodologies also to work from here. The one is to reduce the size of our data. Okay. As you have already understood that we have here the cougar habitat, okay, but we want to be restricted in a specific area. This area is the state of the park. Come on. No. No. Yep. Okay. Is the state of the park. Okay, we want to be all around here because this is our main restriction. As using this kind of restriction, this means that this area is our maximum area of working. So the rest of it that is outside of this area, it's not, let's say, optional. So there is a tool which is very useful. It's called clip. Okay. So from the analysis here, we can use the pairwise clip tool. Okay. So for the input, we put the information that we're going to clip, to cut, let's say. Okay. And as clip input, we're going to put the information that we will use it as the one that we're going to use it as a pattern. Okay. So it's like creating biscuits and using a cherky. So the biscuits dough will be in the input features and the cherky will be at the clip features. Okay, so let's put first the streams, not the streams, the stream buffer. Okay, and from here we're going to use the state park buffer 1. And we'll have it as maybe we want to remember that it's the buffer and the clip. Okay, so now that I use the same name as the information that I already have in my database, you see now we have again the override options. Okay, so I won't go through that as I have already done this. So I close the stream buffer and I open the clipped stream buffer. Okay, so here it is. We reduce our information with a clip. However, by using the clip, the attribute table is not the same anymore. Okay, as you understand, the whole other information are expelled. So we keep only the intersection between those two features. Okay. This methodology can be used, I mean, in if you have big data sets or big data and you want to exclude a small area, so you have to create a shape file, a polygon, which is, let's say, the study area, and from the wider area you exclude a smaller part. Okay, this is a very classic methodology in order to create a smaller new file. But as I mentioned, in this case you create a new shape file. Okay, so that's why you don't keep anymore the prior. So we have the stream buffer and the stream buffer clipped. For sure, the name clipped is not right. If we wanted to be more precise, we had to rename this, and let's say it would be the stream buffer of the national park, okay, which is the one who, the state park, excuse me, which is the one who restrict the area, okay. But I don't like maybe I wanted to put it like that for you in order to see the difference between the data. It's better for teaching, let's say. So, okay, this is the first one. Let's do the same thing also for the road. So, instead of closing this tool, you can keep it open as your clipping feature is the same all the time. So just change the input feature. Let's go to the highway buffer. Okay, and for sure you will have to change here the name. So highway buffer clip and run. Okay, so we don't need the rest of the buffer. So we only keep now the data that we are restricting in this whole area. Okay, so what else? Let's do the same thing for the slope. And for the slope, I think somewhere here, here it is. Okay. If you don't see it, I will put it here for you. On the highway. Okay. So we have clipped only the data of the slope, the steep slopes. Okay. I put it at the back again. We have done it with the streams. Okay. With the highway, okay, and we miss the vegetation. So I have already done or not? Not. Let's do that. Okay, so vegetation. Here you are. This does not have any buffer, so it's vegetation clip. And here we are. And because vegetation is cover everything, we will have to put it here. So in here now, we have whatever we want in order to point the best information where for the cougars to walk. Okay. So there is another thing that we haven't done it, which is the national forest. Okay. Let me check, put the national forest on top for that. Okay, so there is, and let's say small area here, as you see. Okay. Where the national forest is interacting with our area. And we want to be, I think, let me remember this part. But if I remember well, we want to be in the national forest. Well, okay, we can, yeah, we can assume that. Why not? So we want to be also restricted instead of not only from this national state, but also from the national forest. Okay, so we want now to combine all this information. So there is a tool to do that, which is called pairwise intersect. So this tool, I have it here. Yeah, here it is. It's the pairwise intersect. So here we can input all the features and find their intersection. Okay, so let's start with what? Let's start with the clipped highway buffer. Let's start also. Excuse me, no. There's something different here. We just don't want to find the intersection of everything. The buffer zone of the highway is an area of exclusion. So we have to take out this area from our, let's say, whole system. Okay. So for that, we will have again to use the pairwise clip, okay, of no, we will leave that for the end. It's better to leave that for the final step. Okay, let's go back to the pairwise intersect, but we won't use the highway at this point. Okay, let's close that. Good. So what we need is first the buffer of the stream. Perfect. Because in this area, the cougars can find water. Let's go for the vegetation because this is the vegetation which cougars like. Let's go also for the slope, which in here, why? Okay, it's not a problem. So if you saw, depending on our data, we are getting some errors because we are trying to combine more than one, no, more than two information here. But as we have everything clipped, okay, we have everything clipped on the first constraint area of the what's the name again? I always forget that. The state park. Okay, we have two constraints: the state park and the national park. So we want to find this intersected area. Okay, and keep the whole information from the optimum data sets. So while we have all the data sets, let's say, clipped and formed as the state park. So now we can directly, so pairwise, we can directly filter them with the national park, okay, which is the second constrainer here. So instead of doing that between them, here we can do it one by one with the national park. Okay, so the national forest. So we can do that national forest with the vegetation, let's say first. So in this case, unavoidable, we are going to create new shapefiles every time that we are going to do this intersect between them, and every time we are going to to do that in order to find the final product, to go to the final product. So let's go to change the file, the folder, sorry, for the deliverables, and we are going to name that is National Forest and Vegetation. So let's say NF with VEG. Okay. This is just to remember what features have we intersected. So let's intersect this and let's check. Okay, so now we have in this, let's say, in the national forest, we have also the information of the vegetation, okay, which is the best, let's say, part of for the cougars to live. So the national forest now it's in here in the national state park, okay, and we can start doing this intersection step by step. So in the national forest with the vegetation, we will add here the stream buffer. We change the name. Okay, so the stream buffer goes away. So now in the new data set here, we have another polygon. Let's see again the buffers. Do you see now how it starts to look like? Okay, let's check again. Okay, I move on. No, I have a selection. Okay, so here we're going to the stream, and from here we will put also the what do we miss? Stream vegetation slope, I think. Yeah. Hmm? Okay, now we have intersected also the slope. So you see how this final area is started reducing? Hmm? And also it's not only reducing because we intersect, but also the database, it becomes more and more. So we find areas who are having all the information, okay, from all the data sets now. And I think, so the slope is finished, the vegetation is finished, okay, state park is finished. Okay, so there's the final step. Also, you have to go, which is the road. So now we will go back to the clip, and from this area, there is a part where the road is passing through. So from this area, still the cougars cannot be, let's say, be around. So from here, we will have to clip our, our National Forest Vegetation Stream slope from the highway buffer of 500, or it could be also a clip. So let's say here we have the final cougar habitat. Okay, and I want to do the exclusion, sorry. Give a moment. Why, I did it opposite? Oh no. No, still I'm getting the same result. Why? I don't understand.
It's the other way
So
around.
clip the intersected.
I think we have the input feature should be the
The
highway
highway.
buffer.
I did it now, but I got the same result. And this was the weird thing. Okay, let's see. It gets the same thing. Hmm. This is not logic. I want to check something. Maybe if I go to the old tool. Okay, let's go back to the old school. So here we clip using the road and we get, okay, let's see of that. No, still the same.
Shouldn't be the shape files other way around. I'm always confused with the clip. I really don't understand this order. Which shape file goes in the first line and which one is in the second? I'm always confused. But I think it's the other way around. The buffer of 500 meters should be clipped from the total, which is this brown area anyway.
The weird thing is that we did it on the opposite and we got the same result. You see?
Yes.
It's the same result. I think this is due to the size.
I think you can, there is another order, it's like exclude or something like that. From one shapefile to another. I think there is a.
Yes, but I wanted to use the clip. Give me a moment. No, the same thing. Okay. No. Maybe the intersect will, the pairwise intersect will help in this case. So we intersect this with the clipped road. Okay, let's leave it like that in order to check. No, again, we got the same thing. This is very weird because I have done it already with the clip. I mean, in the past, not now. And it worked. So I don't know why is this done like that. And you saw I am also doing it the opposite and gets the same thing. Okay, well. Ah. But now we have this small area here. If we exclude this small area with the other area, maybe it work. So from here. Oh, okay. In this case now, we won't use the clip because there are two clips, okay? Is the analysis clip that we try to use now, which is whole data set from another whole data set. But now, because of this weird, let's say, intersection, we will have to use the clip of the menu edit, okay? On the menu edit, we use, let's say, tools also like here, okay, all of these. But these tools are, let's say, not creating a new shapefile or a new dataset, but they affect your own dataset, okay? I didn't want to use this, but we will have to do it in this case. And there is also here the clip tool in the divide section, okay, which is now different. So in here, you select from the two different, let's say, elements, which should be discarded or preserved, okay? So here we will have to discard both these, okay? Huh? Let's say we will have to discard these. Oh no, wait, I'm not sure. Okay, in order to be more safe, it's better to do also here in this shape file before doing that, to do a dissolve boundaries. It's much better to be sure that this will be only one let's say, polygon. Okay, good. So we're going back to the modification, to the clip, okay, and we have the rest minus this, okay? So we just have to select all of that and discard the area that intersects, okay? So let's go with that. Oh. It makes my life difficult. To be honest, I want to keep this structure here of the final, let's say, dataset that we are going to create, but the modification here does not work with that.
I think the initial, the yellow, The yellow should be
Uh,
one polygon.
Yeah, this is the main issue that we don't want to do that. If we do
Yeah.
also dissolve boundaries, it will become one, okay?
Huh?
Or merge, for example. But we will lose all the
Yes.
information that we have kept using the intersects methods,
Huh?
okay? So here we have all the information from the several databases. So for example, we want to provide this final product to someone, okay, who would like to know about the uh, inner information. We don't want to miss this information. That's why I'm very skeptic here about how to exclude this area, let's say. Uh, Probably its main issue is that we selected more than enough, let's say, polygons here. Uh, maybe we can go to the selection by location in this case. So we would like to select from this zip file, okay, the yellow one, to get only what intersects with the feature of the second one. And no, it selects everything. I thought so. Or we can go like here. Still selects everything. That's fine. The worst case is that we will have to clip polygon by polygon. This is the worst case, but maybe it's something that is unavoidable. So, for example, we select, let's say, no, still I don't like this option. There should be something else in this case. No. You see, it doesn't let me do that, the clip. It is closed. No, it was easier. It was easier. Okay, so let me summarize you what here was done. So if you are an old user of ArcGIS Pro, this is an issue because the clip tool of the edit stage here and the modification of the features was changed at some point. I mean, around ArcGIS Pro 2 version, okay? So it's changed. In the past, we had to select between the data that are going to preserve and the data that are going to clip. But here, and I forgot about that. I'm very used to the old system. But here, let me open again this thing. The clip in the modification, it does not need to select all the shape files. It needs only to select the one that is going to be excluded for any other intersected layer. So if we had even more layers here and we could just click on this specific part, and this specific part would be discarded from all the intersected layers in this case. So it just needed one click to click the specific polygon. Okay, so while it did that, I just hit the clip. So, and here we are. Okay, so now this area is the one that can for the best location for the cougar to be first restricted under the national forest, uh, to also be in the area of um, the state park, okay, and also answers the question, all the questions about the best location for them to live, okay. Okay. Questions. This is the time where we have to do the questions. Okay, you have already uploaded, all of you, this exercise. Okay, this is not an exercise that you are going to be graded, but I would like you just to go through for the final step, let's say. Okay, just go through another time and do also the final procedures in order to get to this result. If you find any problem, we can, let's say, I can help you remotely because we don't want to discuss it again during a class. And if you want to share me your project, please do so, because you see, there are many uses on this methodology, okay? Which is something that I want to discuss now. And before doing this discussion, if you have something to add, please.
Can I ask something? It's very difficult to follow an exercise through a video. Can we have the criteria written? Yes. For example, I want how can I say? Cougars live 500 meters away from
These
highway.
criteria. Okay, the
Those
storyline,
are
let's say.
criteria, and for me, it's very difficult to follow up with a video. A video of 2.5 hours that I had to see before, it took me like 4 or 5 hours. It's very difficult. If I had the criteria written, I would do it like in a half hour.
Okay. Okay. The point is also to follow the video, because we have some discussions in the video, some tips. It's not just doing the exercise. Okay. It's also by following, when it is an offline, let's say, it's still a class. Okay. But I do understand what you say, because you may need a memo for the numbers, for the settings, for example. So probably if like this exercise has this kind of memo, you will need it. I can update where at the section of the assignment there is a description. Okay, I can update this and put there also the numbers in order to, just to put the same options. Yeah, to have the same results. Yeah, I can do that. I can do that. And you are right. It's you took note for sure during the video, and this is a very good thing. But probably this should be done from the very start. Okay, I will keep that in mind if we will follow any of this kind of similar exercises later on, to provide you also the numbers, not only in the video, but also as a note. So, I proceed with why this methodology is very important. Okay, imagine that you want to build to find the best location, let's say, and build that was the name, a factory for processing garbages. Okay. Um, does anybody Greek speaking knows how to translate the hita? It's difficult.
You usually call it dam.
No, it's not a dam.
It's a processing.
It's a processing dam. Maybe you can put also the dam in there. I mean, in the whole title, you know.
ChatGPT says sanitary landfill or municipal waste landfill.
Landfill.
Landfill. Yeah, yeah.
Mm.
Okay, this is the terminology. Perfect. Thank you. So, if you want to find a place where to do a landfill, you do understand that are many criteria all around. Here we used only 4 criteria. Okay, I don't remember all of them. I mean, for a landfill in order to be applied. But imagine that there is a distance from the rivers. You have to be a specific distance from areas uh, with, I mean, from villages and towns and etc. Specific mechanical properties for the bedrocks, for example. Okay, you have to be far away from specific faults. Uh, I mean, for tectonically active areas. So there are many other variations and options that you will have to take in account in order to find the best location to build something like that. So by getting data from different authorities, okay, because there is no one authority giving you data on that, probably you will have to create your own data or modify data and make your own shape files. You will have to go through these procedures in order to pinpoint the best places in order to build this kind of landfills, for example. And I mentioned landfills because there is also the so-called NIMBY uh, uh, law, let's say, which is not in my backyard. So not all people would like to have a landfill close to their houses. So the one who are taking the authorities who are taking who has to solve, let's say, this equation to find the best place, they have to be very accurate, and nobody will tackle, let's say, their final selection, let's say. So GIS are very important for this kind of pointing these locations. However, you need to have all these parameters in mind and to be aligned on these kind of parameters. So in these, let's say, exercises, the parameters were given from experts, okay, from the Council of Forest and etc. In other cases, you will have other experts giving you this kind of parameters, okay, or regulations uh, providing you these parameters. So every time we will have to be very careful about how to apply these parameters for the final products. Okay. from all, okay, now I don't need the GIS. It's better to look at you. So after this exercise and the resume of this exercise, except of okay, the practical part is it's very important to know when you will create new data sets. Okay, it's very easy. You saw what I did. I mean, now just by playing, I created even more. I mean, 8 more shape files that I didn't need it, to be honest. Okay, just by playing with my data. At the end of a procedure, let's say, that you're going to do of a project, you might have 20 or even more data sets that are intermediate to reaching your final product without, I mean, really need them. Okay, this will be a headache because you will have to go through cleaning your data, which is it's very important. Okay, to be tidy with your data. So if filtering is something that works for you, keep filtering. It's a good choice. Okay. If filtering doesn't work for that, go to the intersect of the data. Okay, because this will reduce creating more data sets. If exporting data sets from a shapefile to another to create another shapefile, it works for you, it's okay, do that, but please do it in different folders than your initial data. And finally, if you have to do clip in order to modify the already data that you have, do so. If you are not sure what you are doing, because now I was playing, I didn't care about my data. Okay, but if you are not sure about what you are doing, please keep copies of your different versions. Okay, and it's very easy to get names of shapefiles like forest, clip, buffer, and export. I mean, it's the names that the default part of the ArcGIS is using. Try to remember to rename your files in order to track the stages, okay, of your work. And this is the resume from my part. So, questions? Oral crystal clear? Okay. So, thank you guys for your time. You have more another class, I think, huh? Right? Okay.
I
So,
think we don't have, guys, do we have a class after? I think no.
it's
Offline.
offline. It's offline.
Fine.
Yes.
Yes.
I'm sorry, I don't know.
Mm.
Okay, so have a nice Saturday then.
You too.
Thank you.
Thank you. Bye bye.
Thank you.
Thank you.
Bye.